We will have corrections Sunday and Monday, and I'll send out emails about those. When I'm gone, feel free to message me if you have any questions on problems. I'm happy to provide support. Today I want to talk about slope of the tangent line. So what do we mean by this? Well, imagine a picture here. So here we have a picture, and a tangent line, tangent means that a line that just touches the graph at one spot. It doesn't go through it, right? So not like this line. This line would go through that point. That's not a tangent line. Not like this line right here, because this touches the graph twice. It just needs to touch the graph one time. So this is an example. Here's another example of a tangent line. Here's another example of a tangent line. In fact, there are infinite tangent lines associated with a graph, because every single point on the graph has a tangent line associated with it. So the question is, why is the slope of the tangent line even interesting? Well, here's why. So let's call this tangent line 1. Call this tangent line 2, and call this tangent line 3. So when you look at tangent line 1, has a positive slope therefore the function, the green is some function, therefore the function is increases at the point of tangency. Right, so if you look at tangent line 1 here, right, we see that tangent line 1 has a positive slope, and therefore the function increases at that point. Conversely, tangent line 2 right here there's a zero slope, therefore the function is flat at the point of tangency. And finally, tangent line 3. Slope is less than 0, so f of x is decreasing. Decreasing at the point of tangency. Questions on any of this about the why? So more broadly, why is this important? Well, imagine you have a graph that tells you the profit you make for the number of items you sell. If you know that the tangent line is positive, you should probably sell more. Profit's going up. But if the tangent line is negative, you probably should not keep selling more, because the tangent line is going down, the profit is decreasing. It's very helpful in talking about real-life applications. Now the question becomes, yes, it's important, but how do you actually find it? So, how do you find the slope of the tangent line? How do you actually find it? Well, again, imagine a picture. Have this parabola here. And we have a point on this parabola right here. And we want to find the slope of this tangent line. Now, we don't know the equation of this parabola, so we'll just call it f of x. So we want to find the slope of the green line. So in order to find slope, we need to remember slope equals y2 minus y1 over x2 minus x1. So we need 2 points. Right now we have 1 point here. I'll call that point P. So what do we know about point P? Well, we know point P is on the original graph. We don't know what the x-coordinate is. Maybe it's 12, maybe this is 11, maybe it's 8. So I'll just call it C. Some point. We don't know what it is. Call it C. The x-coordinate is C. The y-coordinate, I would take C and just plug it into this equation. I'll get the y-coordinate. So maybe if this was x squared, I would just plug in C squared, answer. Maybe this was x squared plus 8, plug in C squared plus 8. I don't know what it is, but I know that if I could just plug it into this equation, life would be good. So we'll just call this f of C. In other words, f of, if it's 10, f of 10, f of 12, f of 18, f of whatever. Any conceptual questions so far? But now we have a problem. In order to get the slope of the green line, we need another point. We only have 1 point. Get it? So like right here. So we know the x-coordinate here, but I have no idea what the y is. So somehow I got to get another point. And in fact, it's not possible to get another point here at the level we are at now. We have to do something else. So what if I did this? What if I drew this right here? I drew this line. And this line touches right here on this point Q. So I could find the slope of this red line, bless you. I could find the slope of the red line by saying y2 minus y1 divided by x2 plus 2. So let's do that. Let's call point Q somewhere on the graph. See, Q is also on blue, also on the original parabola. Q has some x-coordinate, let's call it x, we don't know what it is, and some y-coordinate, let's call it f of x. And so the slope would be what? It would be f of x minus f of c, all divided by x minus c. That's the slope of red. Conceptual question so far? Yeah, we are assuming that it's like negative 10. But then that would be like a negative times a negative, so it's not positive. But here's the problem, folks, with the red line. The red line has a slope that is like this. That is very different from this slope. The green marker has a really bigger slope than red. Red is not a good approximation. So maybe instead of the red line, I'm like, okay, I know red is bad. Let me draw this line here. So here's the new Q. Same thing, Q has coordinates of x and f of x. And now I'm like, okay, maroon is better than red, but maroon is not as good as green. We're getting better. And by not as good, I mean it's not the right slope. We want green, remember? Maroon is definitely not equal to green. They do not have the same slope. Okay, so let me draw in gray. What if I put gray here? Here's the new Q. Now gray is better than maroon. It's less flat, closer to green, but it's not as good. Okay, so now let me draw another one. Let's draw this black one in here. And now black is like pretty close to green. Certainly the black one is much better than where we started with red. So what are you noticing? As the Q point gets closer to P, the slope becomes a better approximation. And in an ideal world, where would Q be? Right next to P. In some senses, we want to take the limit, here's how this connects back to what we've been talking about, the limit as this x gets closer to C. Because we would ideally want Q to be right here next to C. And we want to take the limit of what? Of f of x minus f of c all over x minus c. Questions? That is the slope of a tangent line. Questions? Okay. So let's apply this formula now. And to do that, I want to begin with this problem right here on the homework. Page 2 right here. All right. So we've got the graph here. And here we go, -2 and 2. Here's our point P. The equation of this is x squared minus 2. I'm not going to draw this Q stuff. That's what I did over here. I'm not going to do this whole thing again. Anyways, we need to use our formula. The formula is this, always this. Always. Got to know this formula. So here's f of x, and our coordinates of P are -2, 2. And now we just need to plug in. So we want the limit as x goes to -2 of f of x, here's f of x. F of c is right here. Here's c. Here's f of c. Remember, c was the x coordinate of the point we knew. F of c was the y coordinate. All over x minus c. Simplifying now. Limit as x goes to -2 of x squared minus 4 over x minus 2. Now what do? I'm going to plug in -2 just like any limit. And what is this limit solving for? The slope of the tangent line. -2 squared minus 4 over -2 minus 2 equals, did anybody see the mistake I made?